welcome to Get Solutions. This is Lokesh. So in this session we have to solve the problem under duality, that is dual linear programming problem. So I will explain the concept after the problem so that you will get a clarity about the concept in better way. Okay, see, in duality, so duality is nothing but duality theorem. Okay, so it is related to a mathematical calculation. See, when we are converting the actual original problem into dual problem, that also represents the same data. Okay, so while again converting that dual problem into primal problem, then we get a same data from that dual problem. Okay, see, this is the actual problem. So this problem will be also called as original problem or also called as primal problem. So now we have to convert this primal or original problem into dual problem. Okay, see, in dual problem, every constraints will be becomes the variables. Okay, so every variables will becomes constraints. Okay, so this is the variable becomes the constraints and this constraints becomes the variable. See, which is the objective function? So ultimately z maximum 40x1 plus 35x2 is the objective function, right? So this subjected to constraints 2x1 plus 3x2 less than or equal to 60 and 4x1 plus 3x2 less than or equal to 96 is the constraint. So this constraints will become the variables. Okay, see, in simple way. Okay, so I am going to put here y1 and y2 instead of using x1 and x2, because we have to convert the primal or original problem into duality, so that here we have to use y1 and y2 instead of x1 and x2. Okay, so ultimately opposite. Okay, so in the problem they have given the maximum. If we want to convert the primal into duality, we have to use minimum. So just opposite. See, one more thing you have to keep it in mind. So these are the constraints, available resources, right? So constraints becomes the objective function and this constraints will become the variables based on the first decision variable and second decision variable. So let's see how the constraints will becomes the variables and how the variables will becomes the constraints in the dual problem. So but we have to form the duality in linear programming problem based on the objective functions and constraints only. See, in dual problem also we have to form the objective function. So the objective function will be denoted based on the z symbol. So what is the objective? That is maximum. So while converting this primal or original problem into duality, we have to use opposite, that is minimum. Okay, is equal to this objective function becomes the constraints, then this constraint will become the objective function. See, 60 y1 plus 96 y2. So if you want to convert primal into a duality problem, constraints will become the objective or variable function and variables will becomes the constraints. So that I am going to denote this constraints based on the z, because we have to add this 60 and 96 to the objective function. See how to form the objective function under dual problem in the sense. So 60 y1 instead of x1 and x2 we have to use y1 and y2. Okay, so 60 y1, so 60 y1 plus and 96y2. So objective function ಇಷ್ಟೇ. Okay, so one thing you have to keep it in mind, constraints ಬಂದ್ಬಿಟ್ಟು ವೇರಿಯಬಲ್ಸ್ ಆಗುತ್ತೆ, ವೇರಿಯಬಲ್ಸ್ ಬಂದ್ಬಿಟ್ಟು ಕನ್ಸ್ಟ್ರೈನ್ಸ್ ಆಗುತ್ತೆ. ಸೊ ಜಸ್ಟ್ ಆಪೋಸಿಟ್ ಆಗಿ ನೀವು ಪ್ರೈಮಲ್ ಪ್ರಾಬ್ಲಮ್ನ ಡ್ಯೂಯಲ್ ಪ್ರಾಬ್ಲಮ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು. ಸೊ ಜಸ್ಟ್ ಇಟ್ ಈಸ್ ಆಸ್ಕ್ಡ್ ಫಾರ್ 2 marks. ಓಕೆ, ಸೊ ಡೋಂಟ್ ಗೆಟ್ ಕನ್ಫ್ಯೂಷನ್ ವಿತ್ ದಿ ಆಬ್ಜೆಕ್ಟಿವ್ ಫಂಕ್ಷನ್ಸ್ ಅಂಡ್ ಕನ್ಸ್ಟ್ರೈನ್ಸ್ ಹಿಯರ್ ವೈಲ್ ಕನ್ವರ್ಟಿಂಗ್ ದಿ ಪ್ರೈಮಲ್ ಇಂಟು ಡ್ಯೂಯಲ್. ಸೊ ಈ 60 96ನ ನಾವು ಆಬ್ಜೆಕ್ಟಿವ್ ಫಂಕ್ಷನ್ ಜಸ್ಟ್ ಬರ್ಕೊಂಡಿದ್ದೀವಿ ಅಷ್ಟೇ. ಓಕೆ, ಸೊ 60y1 and 96y2. ನೌ ವಿ ಹ್ಯಾವ್ ಟು form the constraints subjected to. Okay, so and also you have to keep it in mind, we have to use the opposite objectives. So maximum ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, ಇಲ್ಲಿ minimum ಅಂತ ನಾವು ತಗೋಬೇಕು. Okay, so we have to convert the primal into duality. So opposite directions ಅಲ್ಲಿ ಬರುತ್ತೆ. And also see the symbols here. So maximum here less than ಇದೆ. So maximum less than or equal to or less than or equal to. So in this problem, if you want to convert the primal into duality, we have to use greater than or equal to. Okay, because the objective is to minimum here. Okay, see now, so constraints na objective function alle barkondidivi. So then this objective will becomes the constraints, right? See, 2x1 and 4x1 ide. So therefore subjected to under duality 2y1, so plus 4x1 ಇದೆ. So therefore plus 4y1. Then we have to use, so less than or greater than, less than or equal to ಇದೆ. So because of maximum function, so because of minimum function ನಾವು ಇಲ್ಲಿ greater than or equal to 40 ಯೂಸ್ ಮಾಡ್ತೀವಿ. we have to ignore this x1. so x1 and x2 ಬದಲಾಗಿ y1 and y2 ಹಾಕೊಂಡಿದ್ದೀವಿ. so this objective function becomes the constraints. this constraints will becomes the objective. ಇಲ್ಲಿ y1 y2 ಯೂಸ್ ಮಾಡೋದ್ರಿಂದ ಇಲ್ಲಿ x1 and x2 ನ ಇಗ್ನೋರ್ ಮಾಡ್ತಿದ್ದೀವಿ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಫಸ್ಟ್ ಡಿಸಿಷನ್ ವೇರಿಯಬಲ್ ಬೇಸ್ ಮೇಲೆ ನಾವು ಫಸ್ಟ್ ಕನ್ಸ್ಟ್ರೈಂಟ್ನ ಫಾರ್ಮ್ ಮಾಡಿದ್ದೀವಿ. ನೆಕ್ಸ್ಟ್ 3y1 ಪ್ಲಸ್ 3y2 greater than or equal to 35. See, 3y1 plus 3y2 greater than or equal to this objective function 35. Now the non-negative function y1 comma y2 greater than or equal to 0. So this is the duality for this primal problem. So again, see, if you want to form other duality problem for the dual problem, you will get the same answer. So same answer barlebeku. Okay, so then only your solution will be the right. So again ಈ ಡ್ಯೂಯಲ್ ಪ್ರಾಬ್ಲಮ್ನ ನೀವು ಮತ್ತೆ ಡ್ಯೂಯಾಲಿಟಿ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ರೆ again this constraints will become the objective function. So objective function, so again the constraints will become the objective function, objective function becomes the constraints here. So ಇದನ್ನ ಮತ್ತೆ ಕನ್ವರ್ಟ್ ಏನಾದರೂ ಮಾಡಿದ್ರೆ ಡ್ಯೂಯಾಲಿಟಿಗೆ again you will get the same answer. Okay, so same answer ಬಂದರೆ ನೀವು ಮಾಡಿರೋ ಸೊಲ್ಯೂಷನ್ ಅಂಡ್ ನೀವು ಕನ್ವರ್ಟ್ ಮಾಡಿರೋ ಪ್ರೈಮಲ್ ಪ್ರಾಬ್ಲಮ್ ಒಂದು ಕರೆಕ್ಟು ಅಂತ. ಓಕೆ, ಸಿ ಒನ್ ಮೋರ್ ಥಿಂಗ್, ಒನ್ಸ್ ಅಗೇನ್ ಕನ್ಸ್ಟ್ರೈಂಟ್ಸ್ ಬಂದ್ಬಿಟ್ಟು ಇಲ್ಲಿ ಆಬ್ಜೆಕ್ಟಿವ್ ಫಂಕ್ಷನ್ ಆಗಿದೆ. ಓಕೆ, ಸೊ ಆಬ್ಜೆಕ್ಟಿವ್ ಫಂಕ್ಷನ್ ಇಲ್ಲಿ ಕನ್ಸ್ಟ್ರೈಂಟ್ಸ್ ಆಗಿದೆ. ಸೊ ಜಸ್ಟ್ ಇದೊಂದೇ ನಿಮಗೆ ಕನ್ಫ್ಯೂಷನ್ಸ್ ಆಗೋದು. ಓಕೆ, ಸೊ ಮತ್ತೆ ಇಲ್ಲಿ x1 ಆ್ಯಂಡ್ x2 ಬದಲಾಗಿ y1 ಆ್ಯಂಡ್ y2 ಯೂಸ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಓಕೆ, ಆ್ಯಂಡ್ ಆಲ್ಸೋ you have to form the constraints based on the decision variables. So ಎಷ್ಟು decisions variables ಇದೆ? 2 decisions variables ಇದೆ. So therefore that is objective also, the two objective is also based on the 2 decision variables, and also you have to form the 2 constraints here. Okay, see 2y1 and 4y2 less than or equal to ಇರೋದ್ರಿಂದ ನಾವು greater than or equal to 40 ಯೂಸ್ ಮಾಡ್ತಿದ್ವಿ, and 3y1 plus 3y2 greater than or equal to 35. Then you have to add the non-negative constraint. Okay, see the second problem. See the second problem. Z minimum is equal to 40x1 plus 24x2 subjected to 20x1 plus 50x2 greater than or equal to 4800 and 8x1 plus 500x2 greater than or equal to 7200, then x1 comma x2 greater than or equal to 0. Okay, so this is the primal problem. So you take it as y1 and y2. So this will become your objective. Here already the objective is to minimum. You have to, that is while converting the primal into dual, you have to take it as maximum. Then you have to say, you have to change the symbols also. Okay, so this will become the objective and this will become the constraint. Okay, so solve the problem yourself. If you have any queries, you comment on this video only, so that I will give a clarity about your doubts. Okay, see the simple concept, that is duality in linear programming problem. That is, after solving the two problems under linear programming, that is the duality in linear programming, you have at least 60% knowledge about the linear programming, that is dual linear programming problem. That is how the variables will becomes the constraints and the constraints will becomes the variables. Okay, so that is the major concept in this duality program. Okay, see the concept. Given any linear programming problem, that is original problem, there is another related linear programming. That is, for given original problem, there is another related linear programming, in the sense this is a original linear programming problem and another related program, in the sense that is dual problem. So this will be called as duality theorem and dual linear programming problem. Means, so theoretical concept na itkondu ನಾವು formulation ಮಾಡ್ತೀವಿ. So that will be the one linear programming problem. So that is also called as original linear programming problem or primal linear programming problem. For every original or primary linear programming problem, there is another linear programming called dual linear programming problem, that is called as duality theorem in LPP. Okay, see the duality theorem tells you that and explains the behavior of the one linear programming with the behavior of the another linear programming problem. Okay, so generally we have converting in this duality program, that is we have to convert the primal linear program into dual linear programming problem. So the slight difference between this primal and dual is nothing but, in this primal the objective function will, that is the under primal function, that is primal objective, that is the objective function in the primal, that is in the original problem, becomes the constraints in the duality problem, right? So and also the constraints will become the objective function and objective function will become the constraints. So that is the difference between this primal and duality problem. See, the duality theorem tells that the behavior of the one linear programming with the behavior of the another linear programming problem. That means the behavior of the objective function and constraints in the both the methods, that is in the original method and dual ಮೆಥಡ್. ಸೊ ಯಾವ ಥರ ಬಿಹೇವಿಯರ್ಸ್ ಚೇಂಜಸ್ ಆಗುತ್ತೆ, ಈಸ್ ದೇರ್ ಎನಿ ರಿಲೇಷನ್ಶಿಪ್ ಬಿಟ್ವೀನ್ ದ ಬಿಹೇವಿಯರ್, ದಟ್ ಈಸ್ ದ ಪಾಸಿಟಿವ್ ರಿಲೇಷನ್ಶಿಪ್ ಇದೆಯಾ ಆಬ್ಜೆಕ್ಟಿವ್ ಫಂಕ್ಷನಲ್ಲಿ, ನೆಗೆಟಿವ್ ರಿಲೇಷನ್ಶಿಪ್ ಇದೆಯಾ ಆಬ್ಜೆಕ್ಟಿವ್ಸಲ್ಲಿ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಡಿಸಿಷನ್ಸ್ ಅಂದರೆ ಡಿಸಿಷನ್ಸ್ ತಗೊಳ್ಳೋದಕ್ಕೆ ಈ ಲೀನಿಯರ್ ಪ್ರೋಗ್ರಾಮಿಂಗ್, ದಟ್ ಈಸ್ ಡ್ಯುಯಲ್ ಲೀನಿಯರ್ ಪ್ರೋಗ್ರಾಮಿಂಗ್ ಪ್ರಾಬ್ಲಮ್ ಬಂದ್ಬಿಟ್ಟು ಬಿಹೇವಿಯರ್ಸ್ನ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡುತ್ತೆ. ಓಕೆ, ಸೊ ದಟ್ ಈಸ್ ದ ಥಿಂಗ್. ದ ಡ್ಯುಯಾಲಿಟಿ ಥಿಯರಮ್ ಟೆಲ್ಸ್ ದಟ್ ದ ಬಿಹೇವಿಯರ್ ಆಫ್ ದಿ ಒನ್ ಲೀನಿಯರ್ ಪ್ರೋಗ್ರಾಮಿಂಗ್ ವಿತ್ ದ ಆರ್ ರಿಲೇಟೆಡ್ ಟು ದಿ another linear programming problem. So even though we have converted the primal problem into dual problem, the data will be the same but the behavior will be different. Okay, so that means the objective becomes the constraints and constraints become the objective. Okay, see, for every linear programming problem there is a corresponding unique problem. Yes, of course, for every original problem or primal problem there is a corresponding another alternative linear programming problem. So that alternative linear programming problem is called as dual problem. Okay, so this primal, that is the original problem, will be called as primal problem. Okay, so that is the thing. See, the original problem is called as the primal program and corresponding unique problem is called as dual problem. So that is the same thing. The original problem will be called as primal programming problem and corresponding unique problem will be called as duality problem or dual problem. Okay, next, see, duality in linear programming help the managers in alternative courses of actions. Okay, and also it helpful to take the necessary decision regarding related values. Okay, see, in linear programming problem, when we have converted the primal into dual, it expresses the relationship between the objective function and constraints, so which ultimately helpful to the operational managers to think about the various factors which affect the objective functions, right? So that's why duality in linear programming help the operational managers to take the alternative decisions. Okay, so based on the primal and dual. So ultimately the dual linear programming helps the business organization to take the alternative best decisions among the various objective functions, among the various alternative functions or various factors. Okay, so this is the simple concept. If they asked to calculate or if they asked to form a dual problem, it is just for 2 marks, that's it. Okay, so keep it in mind, solve the problem and see the solution after this video for second problem. Okay, see and cross verify your solution with the my solution. Okay, so thanks for watching. If you have any queries, so please comment on this video so that I will give a clarity about your doubts. Okay, so thanks for watching once again.